Okay, let us begin. What do you think about this problem? When you are given this problem, which part you see first? Is it the figure of or the okay, the figure. From the figure, do you know what happened already?
Yes, kind of.
Kind of. Uh, so what happened? In the figure, yeah, the figure states that you have two block masses, M1 and M2, and then uh, you see here x1 equal to 0 is at this point. Okay, so there is a reference point for x1, and this is a reference point for x2. There is a displacement of x1 given in here and x2 given in there. That means the problem intentionally says to you that there will be initial displacement of x1 and x2, and we will see that this will be shown in the transfer function later when you convert the ODE into Laplace transform. Okay. However, I don't think you have learned about modeling this previously, right? You haven't, right? So we will discuss about modeling it first. And actually, that's not my first topic. My first topic is this one. Yeah, we want to find the Laplace transform where the ODE has a variable coefficient. Yeah, that for example, if you have ODE of 5x dot plus 3x equal to 0. So this one, those variables are all constant, not varying with time. However, if you have 5t x dot plus 3x equal to 0, then the t here represents the variable coefficients. You see? So the variable multiplied by the x dot is changing with time. In this case, it's constant. In here, it's changing with time. So how do we solve it if we have this kind of problem? So we will have two theorems on it. The first theorem is multiplication by t theorem. Yeah. The content of the theorem is just these two lines. The above, not important to read. The important to read is this one. Okay. The focus is on the ft itself. Yeah, the ft here, and you have the f here. Okay, and then the ft is multiplied by the t, just like this. Yeah. If we compare this function with this function, which one is ft? 5x dot is our ft. Yeah, 5x dot is our ft. So you can, to be easy, you can consider this part first. Yeah, not the two terms combined together. Okay. So the ft in this case is 5x dot. Yeah, and then we want to find out the Laplace transform of t times ft, which is Laplace transform of t times 5x dot. Use that. Do you understand what I mean? Yeah. Yeah, it's from here, so we rewrite it like this. So based on the theorem, the way to do it is that this is equal to the Laplace transform of minus f prime of s. So minus d over ds, the Laplace transform of 5x dot. Okay. So what is the Laplace transform of 5x dot? Let's say 0 initial condition. 5s xs. Okay, so this is 5s of xs. So this is how we do it. And finally, what's the answer from here?
XS.
There is no x dot anymore. We only differentiate with respect to s. Minus
Oh, minus
5 x of s. S is gone because we differentiated. So when you are in this format, you are in S domain already. Take derivative based on S. Okay, that's how we do it. Is this clear? Another example. This is what? UT, we reserve UT for what? Unit step. Okay, that's unit step. Some of you got it wrong in the quiz. UT. What is UT? UT, we reserve it for unit step. Okay, so it's 1 for all t. For all t, it's 1. Yeah. What is the Laplace transform of unit step? 1 over s. That's correct. So if we want to find out the Laplace transform of t, how do we do it? We want to find out Laplace transform of t. Use this theorem. How to do it? So this is equal to Laplace transform of t times 1, right? Yeah, which is equal to minus d over ds. What is Laplace transform of 1? Wow, 1 over s. So what do we have? So this is minus of
uh, 1 over S minus
okay, minus 1 over s squared. This is equal to 1 over s squared. And this is basically the Laplace transform of t. Yeah, you check the Laplace table. You check the Laplace table. This is what I wrote here. Same thing. Check Laplace table. Laplace transform of t is 1 over s squared. Yeah. Any question? Which one? This one?
yeah, so you put that on
No, it's done already here. That one is different problem. Now here we only discuss the ODE, right? Okay, and it ends here. We get the answer here for this term. For this term, yeah, for this one. So the Laplace transform of t times 5x dot is this. Yeah, that problem is different. Any other question? Brian, is this okay? Michelle? So based on the table, and then we show using the theorem that they match. Okay. Okay, now we see the division by t theorem. Okay, the division by t theorem. The theorem says like this. Okay. You have ft, but then if ft divided by t, then the Laplace transform is you integrate fs. Okay. So see the difference? If you have the ft times t in here, the Laplace transform is you differentiate the original fs. However, if you have ft divided by t, you integrate the original fs. Yeah, can anyone guess from this example which one that we can use to show? 6 and 7, correct? Yeah, we can use this. Yeah, either way around we can use. Okay. Let us try to use for 6 and 7. Yeah, is this one clear? Yeah. So the 6 and 7, if we want to use the division by t theorem, then our ft is what? What is our ft?
He is
Division by t theorem. Then our ft is what in that case? This is our ft, yeah? Yeah. We use ft equal to t times e minus at. Yep. And we know that Laplace transform of ft is what? That one, yeah? 1 over s plus a square. Now the problem, what is Laplace transform of e at? So how to do it? This is just a play of division, yeah? So the way to answer it using the division by t is that Laplace of e minus at is equal to Laplace of t divided by t again. A bit silly in here, yeah, a bit silly, because we can just cross it and then find the answer. But that's how maths is happening. Okay, so this is your ft, that's the t, and how to answer it?
integral
So let's do it here. Laplace of is the integral. What do we integrate? Yeah, that's correct. 1 over s plus a square. Yeah, and this one is this, yeah, is the Laplace transform of the top part. Okay. So what's the result of the integration?
s plus a
What the function that we want to use is this as the ft, yeah?
using t.
Yeah, yeah, the whole thing. This is the ft, yeah. I said here that that's the ft. So what's the result of the integration? This is exactly minus 1 over s plus a. Integrate from s to infinity. Yeah. So the result is
Over s square plus t.
this is 1 over s plus a.
Oh, oh we s. Okay, okay.
Yeah. First you put infinity to here, you get 0. Yeah. And then you put s there, but then there is a minus.
Okay, minus.
Minus comes with minus, it becomes plus. So you get plus 1 over s plus a. Okay. So that's the same with the e minus at. Of course, when you find a problem like this and you can cross out the t before you do the Laplace transform, that's better. Yeah. However, when you have the problem like this is not so. Yeah. You cannot cross t with something inside the x dot. Okay. And exactly the division by t, multiplication by t theorem, that is going to be used for solving the ODE. Yeah. Any other question? Clear enough? Okay. Yeah. Yeah. This is just what I said just now. So we want to solve ODE, but then each of the variable, they are changing with time. So what to do? This is how we do it. Same thing. Okay, I want to skip this. You can read this on your own. The same kind of summary conclusion that you have from here and from there. Same one. Okay. What do you think on this? Any idea? Familiar with this problem? Never seen this?
The homework.
Okay. This is in your homework. You want to find out this one, yeah? So this should be your, you are asked to use the multiplication by t, right? So this will be your ft times t. Yeah. So how do we choose?
Two cos.
Yeah, which one is ft?
Uh,
Let me remove this.
cos 2t. Ya, ini nggak sih? Cos 2t, sorry. Dua apa di atas?
So you want to find out the Laplace transform of 2t cos this one, yeah. So in this case, you are asked to use Laplace transform of t times ft. So we choose ft equal to 2 times cos 2t, of course, so that the t is behind it. Okay, so this gt is t times that one. Okay, so based on the formula, we have to know first what is the Laplace transform of ft, which is fs, yeah. So what is fs in this case? Check your Laplace table. Can you get your Laplace table?
Tuh, omega sih nggak sih? Terus kayak S over S square.
Check your Laplace table.
Omega square. Yes. Oh, kan? Ya, S over S square plus. Nah, 11. Oh. Ah, lu buka aja belum?
Yeah, what's the Laplace transform?
S over S square plus omega square. So S over S square plus.
So it is
2S. Yeah, 2S.
is 2s divided by s square plus
4.
huh?
4.
Plus 4. Okay. Yeah. So how do we proceed? We take the derivative of it. Okay. So let's take L of t times ft, then it's minus d of 2s s square plus 4 over ds. Okay. You can use what? The chain rule.
Yes.
Yes, chain rule. So we put minus first and then do the chain rule here inside. Okay, put the minus outside. The first chain rule you get 2 over
S square plus 4.
okay, and then the second chain rule
Apa ya? 2S square over S square over S. No.
yeah. Do you have the minus in front of it?
Over S. Yeah.
Yeah, we have the minus. Yeah, we have minus, and then here you square it again. Yeah, because in here the power is 1, right? When you differentiate, the power becomes 2.
Ya, juga sedikit kurang ya.
And then you have s over there. Okay.
Salah, cuma differentiate.
And then after that, you just do algebraic manipulation to find out the final form. Okay. So this is the whole thing of the result. So you see, this step is, I think it's here, yeah, it's here. Okay. So this line is here, and then after that, when he differentiate, the minus sign is already multiplied, so it's plus in here. And then finally, you are asked to get the GS at s equal to 0, yeah? So insert s equal to 0 here. What do you get? This becomes 0. It becomes 0, so minus 8 over 16, yeah. It's minus half. Sorry, it's 2s times 2s, yeah. So it's 4s squared. So the 2s here on the front is the variable, is the constant variable, and this whole thing here is the result of differentiation. Okay. How do we get the 2s? It's from the 2s here, yeah. 2s. This one goes up. Which one? This one? No. The left only s squared plus 4. So this left side, I differentiate only the 2s. 1 over s plus 4, that's a constant. Yeah. On this side, the 2s is the constant, and I differentiate the 1 over s squared plus 4, and the result is 2s over s squared plus 4, we square it. Yeah. This one? Oh, from here? From here to here? Okay. Yeah. This minus is here. Okay. This term, I differentiate 2s. 1 over s squared plus 4 is constant. Constant, so I keep it here. What is the derivative of 2s? 2. So we have here 2, and this is a constant. Okay. And on this side, I differentiate the 1 over s squared plus 4. The 2s is constant. So I put 2s over here, constant. And this whole thing on the right here is the the derivative of 1 over s squared plus 4. Okay, so let me write d over ds over, this is minus 2s over, okay, that's the 2s. So how does it get up here? Yeah, how does it get up here? So the way is that the 2s, the 2 comes down, yeah, it becomes 2s, and it becomes the multiplier on the top, and because it is a division, you get minus sign in here. Okay, and then the power increase from 1 become 2. Okay, remember again the rule of getting derivative of the division, yeah, fractional function. Just like when you have a, let's say you have f of x equal to 1 over x. Now this one, what is dfx over dx? How do you solve this? Yeah, so you have x to the power of -1, yeah. -1 comes down, so it becomes -1 over x squared. So the minus sign coming from your power itself, yeah. In here the power is minus actually, yeah. The power is minus. Okay. Not so clear. Not so clear. Let me make it clearer.
Clear, sir. Clear, very clear.
Sure. So 1 over s squared plus 4 is equal to s squared plus 4 minus 1. Agree?
Yes.
So take the derivative of this, you get the d of 1 over ds lah. Okay. So you get the -1 first. Okay, -1, and then you have 2s. 2s coming from here, and then multiply by s squared plus 4 minus 2. Yeah, so it becomes -2s that square. Yeah, -2 because you have -1 in here. You take -1 here and then it becomes -2. Every time you differentiate, the power becomes less and less. Yes, okay. Okay. Anything to confirm? Sure. So you can do it later if you have exam like this. But the exam will look a lot like this. Yeah, so you will not be given a problem, find the GS of this function, find the FT of this Laplace transform. No. You will be given a problem involves ODE and then you will be asked to solve the problem. Okay, you have to first convert the ODE into Laplace transform, solve in the Laplace domain, and then revert it back. And this is one of the example. Okay, let's take a break of 1 minute before we go into this. So let us continue. If you have this kind of problem, you have to first derive the governing equation. Okay, so the governing equation, you have two masses. Draw the FBD first. Okay, FBD. Okay, the FBD, and then we assume, let's say, x2 is greater than x1 in the FBD. X2 greater than x1, so this spring is being extended. Yeah, spring extended. And then because the mass is moving to the right, spring number 1 extended. Yeah, so this is the K1, x1. This is the force coming from x1. And then from spring 2 extended. Spring extended, so it will pull to the right. Yeah, and then the K2, x2 is greater than x1, so this is x2 minus x1, like this. Yeah, because the spring extended, the mass is going to be pulled to the right, and that's because of the difference in the x2 and x1. What if x2 and x1, they have the same displacement? There will be no force. Yeah, no force in here. What about mass number 2. Canceling out, yeah, it will be pulled to the left. Okay, then this is K2. What about K3? Push to the left, yeah, push to the left. Yeah, basically the spring wants to go back to its original position, so it will be pushing the mass 2 back to the left. So that's K3 times X2. Okay, so the equation here, yeah, you know, the X1 positive is going to the right, also X2 positive to the right, and you will be using just sigma force mx double dot. That's the governing equation. So we solve for mass 1 first. That's correct. Minus K1 X1. This one? M1 X1 double dot. Okay. How about this one? This is minus K2 X2. Okay. And then what's next? Yeah, you can either reorganize everything. Yeah, just reorganize everything so that on the right side is 0. Just organize like that. Okay. So let us move this whole thing to the right. Okay, so we write down 0 is equal to, and then plus K1 X1, and then what? Plus K2 X1 minus, uh, sorry, what is it? Minus K2, yeah, K2 X2, like this. Yeah, I bring all of them to the right side. Plus in here become minus. Okay, so I put 0 on the right side. Yeah, if we put 0 here on the left side, it's just like we say, the computer is now being repaired by Anton. Okay, this is a sentence, right? So if we say like this, plus, this is minus, minus a to x2, they have the same meaning. Yeah, but this one says the computer is now being repaired by Anton. But this one says Anton is now repairing the computer. Okay. What about this one? Okay, let's do the same thing. 0 is equal to, yeah, and then plus K3 X3, and then minus K plus K2, sorry, K2 plus K3, yeah. K2 plus K3 X2, and then minus K3 X1. Minus K, sorry. This is K3 X2, yeah, sorry. X2. This is X2, and so this is K2 X1. Right. What is the final goal? Okay, what you need to do here is just to take the Laplace transform.
Good. Oh, okay.
Yep, and then inserting the initial condition into it. Yeah, so you take Laplace transform here, take Laplace transform there. So what happened? Let us take Laplace transform. So here, m1 times s x1 is square. What about the initial condition? No, 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 no. We have that's the initial condition. Epsilon 1 and epsilon 2. So how do we put the initial condition here? So minus what?
Minus x s s s s
S x dot 0, and then minus x0 x1 0, yeah. Okay, and then this one.
Sorry, nggak kebalik itu, Sir.
Huh?
Harusnya sx0 nggak sih, minus x dot 0.
Iya.
Say that again.
X s s x0 minus x dot 0.
Say that again.
Sx0
Sx0.
minus x dot 0.
Oh, okay.
Oh, kebalik. Ini kan selamat.
No, not this one. So I put the dot here.
Yeah.
Okay. So this one is 0, right?
Yes.
Yeah. Remember, you have the s term left later. What about this? It's just x1 of s. Okay.
Yeah,
What about this?
same thing.
Minus k2. Okay, that's equal to what?
0.
Don't say 1 over s, yeah.
Sama.
0, you take Laplace transform, is still 0.
Who did that?
Astagfirullahaladzim. Okay. So what's next?
Make it x s.
Where? Yeah.
Make it x s.
x1s multiplied by a lot of terms, right?
Yes.
So we have m1 s square, and then what else? This one?
Minus m1 s x1.
No. This one.
Oh, epsilon.
Just as x1s. x1s is multiplied by s square m1, and then this one, right?
You got it. I mean,
k1 plus k2,
yes.
and that's it.
Okay.
And then x2. No, x2 is minus, yeah. Minus x2s times k2. And then there is this term. We have minus s times epsilon 1 equal to 0. Okay. What about this? Same thing, yeah. So we have m2 okay, this one. Yep. Or this one. And then yeah, this is equal to 0. And then finally we write this m2 s square, and this is k2 k3 minus x1 s k2. No, we have this one. That's epsilon, right? Minus S epsilon 2 equal to 0.
Between
Yeah.
minus. I don't want the S.
Which one?
Yes.
This one, S.
Oh yeah. X1 0.
X1 0 is epsilon 1, right?
Taruh di belakang.
Okay. If let's say you are asked to find out x1t and x2t, what's your idea?
X1T, X2T.
Yeah, what's your idea? Say that again. Yeah, we have to express x1s first. x1s is equal to some term, but there is no x2s in there.
Yeah.
Yeah, how to do it?
Ini ada dua equation. Bikin X.
Yeah,
sama dengan X1.
X1 over X2 equals.
Yeah.
Don't x1 over x2. No, don't do that.
Sama dengan something gitu.
Ini
X2
okay. Unknown to equation X2.
Yeah, let me write down here the equation. x1s m1s squared plus
Dulu kan nggak usah. Masalahnya di X dulu.
okay. The s epsilon 1, I move it to the right side. Yeah, because that's non-x term. And then this this is k, what k, k2, yeah. Okay, so we want to get single equation like this, and then we have x2 as, but in this equation there is no x2, in this equation there is no x1. Substitution, we can do substitution. Yeah, for example, you use this equation to get x1. So let's see. Yeah, from here, what do we get? X1 of s is equal to, can you do it quickly? X1s is equal to x2s m2s squared plus k2 plus k3, and then minus s epsilon 2, you divide by k2, okay? And that's minus. Is it minus? No, it's plus, yeah, plus. Okay, now you put here to here, and then you obtain the whole thing. Is this clear?
Yes.
Yeah. Yeah. Do you want to continue here? Yep. So you replace x1 by this whole thing. Okay. So that's and then you multiply this whole thing with yeah, and then after that Okay, then you get only x2 term. Yeah, but in this problem, you are not asked to find out what is x1 and x2. No, but you only need to find up to this point. Yeah, you see, hey, wait. You have to solve, right? You have to solve, then you have to go this way.
Yeah.
Go this way, and then you solve it. Yeah, the right side. So for sure, there will be sine and cosine term in your result. Sine, cosine term. There is s square here. And then we also know when you release it, and you give initial condition and you release it, right? It will oscillate. Oscillation means sine and cosine function. So you will get sine and cosine function in the result. Okay, let's move on to the next. This example you can read on your slides. Yeah. So I will not discuss this because we only have 10 minutes. Yeah, what I want to discuss is this. Problem 41. You have to solve for the position of the mass. How to approach this problem?
I want it.
Yeah, you take Laplace transform first.
Like we do on the quiz. Yeah.
Yeah, and then what about this delta function?
E to the minus
I to the power of
Yeah,
minus
there is a delay of phi, not phi, pi.
pi.
or
Delay, yeah, delay pi.
bukan how delay you use.
Huh?
Bukan how delay itu you use.
Oh iya. Kan delay kayak gini. Mulai ada. Delay berarti mulai startnya.
If there is a delay in your time domain function, what is your Laplace transform? Okay, let us review. S, right, not T, right? Your quiz is T, which is why it's wrong.
Apa?
Okay, let's take the Laplace transform for this function. You have x double dot plus 2x dot delta t minus t. Okay, let's take Laplace transform. Each of the term, is there any initial condition?
No. No, everything zero.
Yeah, everything is zero, so we don't consider the s x0 and then x dot 0. Yeah. Straight away, what about this? This will be s square. This one, okay. This one, that's equal to, yeah. Okay. After that, we regroup xs, 2s plus 2. Okay.
XS is equals to IS.
Yeah, this is, yeah. How do you intend to solve this?
There's the inverse function. There's the apa 18 theorem, the table 2 theorem 11.
Table 2,
Theorem 11.
theorem 11. What is theorem 11? Not theorem 11, but entry number 11, you mean?
Yeah.
That's not theorem.
Okay.
That is Laplace transform pair.
Yeah. I mean,
LT pair.
yes. Correct.
What does the LT pair says there?
Plus of
E to the minus s times fs equals to ft minus a times
yes. So we need to Laplace the ft first.
Nah, this one first.
Yeah.
Okay, yeah, this one first, and then that one later. Okay. So what about this?
So if we inverse
So
Laplace that,
yeah, you have to find Laplace inverse first about for the concentrate on this first. That's the FT.
s plus 1 square. The quadratic.
No, this is 2.
No, on the right side.
Yeah. You mean this whole thing it become what? X square plus
1 square. 1 square. 1 square. S plus 1 dalam kurung.
and then you plus 1. How does it does it have a Laplace transform pair?
Yes.
Which part? Show me.
S square plus 2. S plus 2 is dalam kurung S plus 1 square plus 1.
What? This?
Yes.
You mean this? 1 over this one?
Yes.
Yeah. What's the Laplace transform of this? What? 1 or 4? 1, right? Okay, 1. Not 4, but 1.
Yes, 1.
Okay, you said 1, not 4. Not 2, yeah. Okay. So what is the Laplace inverse of this based on the table?
Ini ya kan? Ini kan? Ini kan? E to the power of minus 80 sine omega. Nomor 20 gak sih? Pernya yang nomor 20 gak sih? Tabel A1 nomor 20. Nah itu. Ya kan? Sama kan? Nomor 20. Yang nomor 20 kan?
Number 20. Okay. So yeah. So we use entry number 20, yeah. Okay. So the omega is 1.
Yes.
And this is A is 1.
Yes.
Okay. And it becomes e to the power minus t times sine of t.
Yes.
In that case, yeah. Yeah, take entry number 20. LT pair. So this is our FT, and then so Laplace inverse of XS in that case is what? E minus t sine of t. You multiplied by
U minus
ut minus v. That's it.
Nah, itu harusnya T-nya kurang V juga nggak sih?
That's correct. This is t minus v also, yeah.
Also sin t minus
Sin,
v.
ya.
Yes.
Hati bukan hati bu.
Yeah. So basically what happened with this system is that the t is in there, and then your v is here. It starts to give a response at v, yeah. Okay. And and this is also in your homework, right? What about number 42?
Alah. Oh, wow. What is the log intro? What is initial condition? Wah, ini apa ini? Gua baru lihat. Sebenarnya.
Any idea?
Laplace.
Hah?
Iya ya. Kan bisa gitu x square x.
Yeah. Okay. By the way, don't think about the theorem first. Don't think about the theorem first. What is really happened with that system? What really happened? Delay by what? Delay by a. Okay. It's just a function delayed by a. And by the way, if you have a function delayed by some number, you multiply by ut minus the delay. Why we don't multiply ut minus something with the impulse? Why? Do you know why? Any idea? You see, Laplace transform of this one, right? Yeah, and then if we want to take a delayed impulse, we just write delta of just the delta of t minus a, let's say. Yeah, we don't multiply by ut minus a, just like that function. Why is that so? This one is enough. Because that function we need to multiply with the ut minus a.
Okay.
But the impulse we don't need to multiply.
Which one is the
Just now in the previous problem, impulse, right? There is no ut minus a. Yeah, we don't need to multiply with this. No need to. You only need to. Why?
I don't understand.
Itu lapasnya the minus a. Itu lapas itu the
No. You don't get it? Because the impulse is infinity at t equal to a and 0 everywhere. So we don't need to multiply with this. It's 0 everywhere. So wherever you shift it, it is always 0 everywhere except at that point.
How is it related to infinity, sir?
Huh?
Related to infinity.
Impulse function. You review again the slides on impulse.
Oh, yeah.
Yeah.
Yeah. Then that space.
Yeah, there is a time range for the delta function. But with the e to the power minus t, how does it look like? When t equal to 0, it's 1. Okay, and then after that, it goes like this. And then it is being shifted by a. So what happened is, this is the a, goes like this. Yeah. But what happened from here, from 0 to a? We want it to be 0. Yeah, before a, we want it to be 0. But if we don't multiply with ut minus a, it will become, there is something on it, because, yeah,
lainnya nggak dari satu. Kalau
yes, it will not start from 1. There will be some number in there. If there is no ut minus a, there will be some number of them. Okay. So what really happened with that system is that you have x double dot plus omega square x, and then the input starts only at time equal to a, and the input is e to the power of minus t. That's it. Yeah. So you can solve the problem by s square xs plus omega square xs, and this is equal to 1 over s plus 1. Okay, so you have the xs s square plus omega square, then multiply by that. Okay, so this is already in the form that you want. Yeah, you want it already. You just have to find the partial fraction. Yeah, so a for s plus 1 plus b over s square plus omega square. This one already have the LT pair, right? Laplace transform pair for this format is already in the table. This one also already in the table. Get partial fraction.
Dari kanan dong sekali gini kayak jadi satu one big underline s plus one dalam kurung s square plus s.
Yeah. If you have the Laplace transform on this format, you can just convert it already. Do you have it? No, the whole thing. Yeah, the question is, do you have find LT pair of 1 over s plus 1 multiplied by s square plus. Do you have Laplace transform of this already in the table?
Yeah.
This? Which pair?
Bukan ya, s plus.
Do you have s plus 1? Or s plus something lah? Well, if you find, you can.
Satunya dari mana? Iya, oke.
Sir, how you get the 1 over s?
Which one?
Where would you get the 1 over s?
1 over s plus 1. E to the power of minus t, right? This one.
That one.
80.
Minus 8.
No. Don't put the a first. That's what I want to say in the beginning, yeah. What I want to say in the beginning is that you have a system, the input is delayed by a. Okay, so now you just compute the response as if there is no delay. After that, you put delay. After you get the result, then you put the delay.
Oh, okay.
Let's say, yeah, an example, your xt is sine omega t. Let's say it. After you compute this is no delay. Then you put the delay, xt will be ut minus a sine. Yes.
Oh, to make it easier, guys.
You assume A-nya sekarang 1.
No, I don't assume a.
Iya nggak ada dulu. Nggak ada.
I don't assume a at all. Okay.
Ini. Kan minus. Angkat T doang. Satu kali T. Ada satu. Ya.
So don't eat the theorem as it is. Jangan ditelan teoremnya mentah-mentah, tapi
Buat sesuai hati.
you see what really happened with the system. Okay. Okay, is there any pair like this?
Apa ya?
Do you have the pair? Okay, if there is no, then you have to split.
Ini kita
Ya.
harus cari dulu nggak sih? A-nya sama B-nya.
Of course.
Baru
Of course.
dapat, baru bisa.
Yes, once you find out the A and B,
Then we can see if we can use it.
then you convert only its term. Yeah, this one become e minus t, this one becomes cosine. Yeah,
Hopefully
cosine or sine. Okay, I think that's enough for today. You have something else to do,
yes.
so feel free to ask me if you have other question. Okay, I'll see you again on Thursday.